Right. Okay, so I just have like a super short preamble, and then I was gonna dive into Blender and just start drawing stuff. Um, but as far as the preamble goes, in the very limited time of this workshop, this will be a kind of a whirlwind. When I talked to Saleh, there are two ways that workshops like this can go. Someone like me could either go really, really slowly, and we all follow along together, and then the workshop leader builds something, maybe a molecule or a protein, and everyone else does the same thing, and you only go as fast as the slowest person in the room, but we all go together. Or you show off a couple of things and no one follows along, and it's like 10 times faster. So we sort of opted for the latter. But the theory was it's all recorded, so you could go back and look at things and slow them down if you ever want to sort of reproduce any of the work that I'm doing today. I will just say, there's a tremendous amount of great information on using Blender, specifically for scientific purposes on YouTube. Just to name kind of 3 YouTube channels, there's Andrew Price, who, that's not for science. He's just a Blender educator generalist, but probably the most famous creator of Blender tutorials. He has a particularly famous tutorial series called the Blender Donut Tutorial Series, and it takes you from complete beginner, like never used Blender before, all the way to making pictures of photorealistic donuts, which again is not scientific, but you learn, almost everything that Blender has to offer in terms of its, even basic and intermediate functionality on the way. So if you're piqued in interest, I highly recommend that tutorial series. And then of course there's Joe Mannion. I have a feeling that Sally reached out to Joe, for this workshop initially. He also goes by CG Figures on YouTube, and he's made several hundred YouTube videos for material scientists, and material science ecosystems, specifically using Blender for those purposes. So it's a great channel. And then if you haven't heard of Rio Mizuta, also just an incredible resource. And both Joe and Rio, in addition to having lots of tutorial series, they also offer a lot of like pre-made assets, so you can very quickly build scientific diagrams from components that they've already made. And I think because this is an optical-based conference, Rio actually does a lot of stuff with optical setups and lasers. And there's a lot of already developed components and lenses and equipment that you don't have to model yourself, you can just download and use. Okay, that's it. That's the entire preamble. So I'm going to dive right in. If you do have a laptop and Blender installed and you want to sort of follow along, you can, although I will go way too fast for really being able to follow along. I will check the comments periodically. So if somebody all of a sudden wants to interrupt with a question, that's fine, go ahead. So what are we doing today? So I'm going to show how to make so my research is in metal organic frameworks, and so I was going to spend a few minutes just showing how to make this simple schematic of a MOF unit cell. And I do this because it's very pedagogical. It's very, very simple, and it'll cover a lot of the basics of how to use Blender. And then it's really easy to make this sort of animation on the right. And then, at the request of the organizers, okay, we'll just really quickly make some laser beams, and then we'll make graphene, hexagonal boron nitride, and molybdenum disulfide, which are all virtually the same thing. So once you make one, it's really easy to make the others. And then, I don't know if we'll have time in this limited workshop, but I was also asked if I could show how to make an optical metasurface. It's important for me to point out that I don't actually really understand metasurfaces. I'm not an optical scientist person. But this is an image that I made. So I Googled optical metasurface, and I found the image on the left, which was from this website, flexcompute.com, and they were basing it off of some science paper on using these metasurfaces. And so just for the purpose of this workshop, I thought, okay, I'll try and recreate that, and I did. And so I don't know if we'll have time for that. If we don't run out of time and you're interested in making a figure like this, you can maybe reach out to me afterwards, but I'll try and get there. Okay, so I'm going to pull up Blender.
It sounds like you're interested in recreating a figure related to...
My phone started talking to me. Okay. All right, so when you open Blender, this is what you see. Okay, so you open up with this gray cube in the middle. This is the default cube. The only difference between what you would see if you open Blender now and what you're seeing on the screen currently is in the bottom left-hand corner, I have a little display of what keys I'm pressing. So if I push the G key on my keyboard, the letter G pops up. If I left-click with my mouse, it indicates that I'm left-clicking or right-clicking or whatnot. Let's just quickly build a moth, because if you just going back to the reference picture, okay, it's just made from some cubes and rectangular prisms, and so we even start with that. So the first thing we're going to want to do is we're going to want to make this cube red. So in Blender, by default, everything is in grayscale. You have to change the rendering mode, and you do that by going into the top right-hand corner, and there are these 4 circles. So we're going to pick on the circle at the top right. And now, even though it's still gray, now we're in the sort of rendering mode that shows colors. So then I need to assign a material to this cube. So I'm going to go to the bottom right and click on this red checkered sphere. And if I didn't have a material, you would click New. And then where it says base color, there's a little white box here. You click on that and you can assign a color. Okay, so now we have one node from our metal organic framework. And it's good to name these things. So I'm going to call my cube a node, and I'm going to call this material metal color. Okay, so now I am going to start duplicating this cube. The shortcut for duplicating a cube is Shift-D. So I'm going to press Shift-D, and then I'm going to move it on the y-axis by 8 units. So I'm going to push 8. And then I can select both of these by holding Shift, left-clicking on both, and then I can duplicate them by pressing Shift-D again. Then constraining movement to the x-axis. I'm going to press X, and I'm going to press 8. Or I can press -8. And now I have 4 of them. And I should say I would never go this fast normally when I teach my class and people are following along. But on the premise that we're not following along and you can go back later, you know, this will make more sense when you see it, when you watch the recording and slow it down. So now I have my 4 of my metal corners. So I'm going to hold down the Shift key and left click, and select them all. Then I'm going to duplicate them all by holding Shift and pressing D. And then I want to move them on the Z-axis. So I'm going to press Z. And I can move them with my mouse, but I specifically want to move them 8 units up. So I'm going to press 8. And now I have all the metal nodes of my metal organic framework. Again, if I go back to my reference. By the way, is my screen still sharing? Yes, it is, I can tell. Okay, so we're done with these corner units. So now we're just going to add these bridging turquoise units. So to do that, I'm just going to add another cube and then just adjust its dimensions. I'm going to, so in Blender, whenever you add an object, it appears where you see this white and red ring. I don't know if you can see it on the screen, but in Blender, that's called the 3D cursor. And you can move that white and red ring to other locations, just in case, so you don't spawn one object inside another. So I just moved it arbitrarily off to the side. And now if I hold Shift-A, I can add a new object. So I'm going to add another cube, which will be gray. So I want to make it blue. So I'm going to go to the bottom right-hand side, click on this red checkered sphere, then click on New, and then click on this base color and change it to this turquoise color. And now I just want to adjust its dimensions. I want it to be long and thin. So I can scale it so that it's longer on the, well, actually, first I'm going to reposition this blue cube. I want to put it exactly in between two of my red cubes. So I'm going to select one red cube, hold shift, click on the other red cube, and then I'm going to put my 3D cursor exactly in between these by using the shortcut Shift S. And then I'm going to choose with the bottom option, cursor to selected. And then I can click on my blue cube and then move the blue cube to the 3D cursor by holding Shift S and saying selection to cursor. And now my blue cube is between my red ones, and now I can just adjust its dimensions. So I'm going to make it longer along the y-axis so I can scale it, and the shortcut for scaling is pressing the S key on the keyboard. So I'm going to press S on the keyboard, and then I'm going to press Y to scale it on the y-axis. And I could eyeball it, but I could also type in a number, so I can multiply it in the y direction by, say, 3, which looks like it's the exact length that I need. Then I can push enter, and then I want to make it thinner, so I'm going to again scale it, and I want to scale it in the x direction by 0.5 and scale it in the y direction by 0.5. Whoops, sorry, not the y direction. Scale it in the z direction by 0.5, and now I have one of my blue linker units. It's a little dark in here, so I'm going to take my light that I have off to the right. That's what this object is. And on the right, I'm going to change it from a point light to a sunlight. That's too bright. I'm going to reduce the strength to 3. And now everything is well illuminated. Okay, so back to where we were. I'm going to pick my bridging object, and I'm going to duplicate it again. So I'm going to press Shift D to duplicate it. I'm going to press X to constrain the movement of the duplicated object on the x-axis, and then I can move it by hand by dragging the mouse, or I can just type -8 to move it exactly, -8 units. Then I can select both of these and duplicate them by pressing Shift D and Z and then 8. And then I can duplicate again one of these linkers, so I can press Shift D, and this time I'm going to rotate it by 90 degrees on the z-axis. So I'm going to press R, then Z, and type 90, and I'm going to put it exactly in between these two cubes. So I'm going to select these two by holding the Shift key, and I'm going to put the cursor in between by pressing Shift S and saying cursor to selected. Then I'm going to click on my blue linker and press Shift S and choose selection to cursor. And again, I'm just going to duplicate everything. This is why this is a good pedagogical exercise, because there's a lot of repetition. So I'm going to press Shift D, then Z, then 8. So if you do this yourself, you'll get very comfortable with all the Blender shortcuts rather quickly. And then I'll press Shift D, then Y, then 8. And now I do this again, but on the Z-axis. So I'm going to put my cursor in between these two red cubes. I'm going to duplicate this linker. I'm going to rotate it on the y-axis by 90 degrees, RY 90, and press Shift S and say selection to cursor. And then I can duplicate this, Shift D, press X, type -8, select both of these, press Shift D to duplicate, move it on the y-axis by 8. And then I am almost done. Again, in reference to the picture I was trying to make, we're almost there. The last thing is to just select all 4 of these and then duplicate them and move them on the z-axis. Shift D, Z, 8. Duplicate them all. Shift D, Z, -8. And then select these and say Shift D, Y, -8. Shift, wait, I realized slightly inefficient there. I should have selected all 4 of these. Shift D, Y, -8. 1, 2, 3, 4. Shift D, Y, 8. And then in the X direction. 1, 2, 3, 4. Shift D, X, 8. 1, 2, 3, 4, Shift D, X, -8. Okay, so there is our little cartoon of a metal organic framework. And it's not really useful to use Blender if you can't output things and put them into a PowerPoint slide. So in Blender, there is an internal camera which you can position. So right now, if I was to render an image, so export an image, it would export whatever the camera sees. So what does the camera see? Well, there's a movie camera icon, if you can see where my cursor is, and if I click on it, or if I press 0 on the numpad, if you're using a full-size keyboard, it will show me what the camera sees, which is this zoomed-in corner section of the moth, which is not what I want. So instead, if I navigate the viewport to an angle that I did want, let's say like this, I can reposition the camera by using the shortcut Control, Alt, and then 0 on the numpad. And now this is close to the view that I want, but not quite. A little bit of my moth is cut off. So one thing that you can do is you can click, once you're in the camera view, so if you click on this movie camera icon, you can click the lock icon underneath. And now when you rotate the viewport, it will also move the camera. And so we can sort of zoom out a little bit and adjust this to taste. And then once we're happy with it, we can unlock it. And now we can look around, but whenever we want to render a screenshot, we can go back into the camera. Okay, so very important to know how to export an image from Blender. So if I was going to go and say render, so to do that, we go up to the top left-hand corner and we say render image. And if I was to save this, so I'd say image, save, and I will put this, say, somewhere on my desktop. I'm going to say test, moth, image. And let's say that now I wanted to put this into a PowerPoint slide for a grant proposal or something. So I'm going to just find my image from my desktop. There it is. But one problem is that there is this ugly gray background. And so to get rid of the gray background, in Blender, we can render this with a transparent background. And to do that, we will go into the render properties, which is this tab, and we scroll down to where there says film, and then you can click transparent. And now the background won't be included. And if we say render, render image, we'll see this checkered pattern. And if we save this, so we'll say test moth image 2. And now if I was to import the second file, we can see that the background is transparent. There's one more, and this may sound like a boring detail, but if any of you are going to use Blender later, this is a common source of frustration, is sometimes you want to, actually not sometimes, often in science we want to render things with white backgrounds. But by default, Blender will give you only slightly off-white backgrounds, which look really terrible if you're putting your images into a manuscript or on a PowerPoint slide that has a white background. If I go to this red earth icon here, the world properties, I can change my background color to white. And let's ignore for the moment that my moth looks sort of washed out. If I was to render this image and then save it, and I'll save this as the third version of my image, and then import it, insert, file, this device, right, you can see that it's clearly not white. And that's because in Blender, it's using some fancy color management filters. So everything goes through as color management filters, which artists love, but I think it's not really appropriate for scientists. So the best thing for science is just to go into the render settings, go to the very bottom where there's color management, where it says view transform, and just say standard, which basically just turns off color management. And now white will be white, and artists will hate it, but it's great for scientific diagram making. Okay, in the interest of time, okay, I'm going to leave this moth and move on to the first requested feature from one of the organizers, which is just making a laser beam. So this is really, really simple. It'll take about 2 minutes. So what I'm going to do is I'm going to just open a new Blender file. So I'm going to go File, New, General. So this is where we started. Let me turn on my screencast keys so you can see what keys I press. And I'm just going to, just at the very beginning, check what my camera sees. So I'm going to look through the lens of my camera. So if I was to render an image, this is what it would see. Although I'm still in this sort of grayscale mode, so I'm going to switch it to, I'm going to go to the top right-hand corner, go into rendered view, and I'm going to delete this cube. Okay, and we want to add an object that represents the shape of the laser. So in this case, it'll just be a cylinder. So I'm going to press Shift A and add a cylinder. And then I want it to go along the x-axis, so I'm just going to rotate it by pressing R, then choosing the axis that it'll rotate around by pressing Y. If I move my mouse, you can see it's rotating around the y-axis, but I specifically want to rotate it by 90 degrees, so I'm going to press 90. And now I want to make it just much longer along the x-axis, so I'm going to scale it along the x-axis, and I can do that by pressing the S key to scale, and then the X to scale along the x-axis. And this I can eyeball as long as it goes off the ends of the screen. So I'm just going to just scroll my mouse until it's going off from a long way in one way and going off the screen on the left and right. By default in Blender, objects have this sort of faceted look. If you right-click on an object and then left-click on Shade Smooth, then it'll take away those facets. So now I want to make this laser a little narrower, so I'm going to scale it along the y-axis and the z-axis, and I can do that by individually scaling the y-axis by, say, 0.2, and then the z-axis by 0.2. Alternatively, if I undo twice, the shortcut for that is I can scale it, so I can press S to scale, and I can hold Shift X, which will scale in the other two axes, so it just won't scale in the X direction. And I can type 0.2, and it gives me the same thing. So now I want this thin column to glow some color, and I want the background to be pitch black. So I'm going to make the background pitch black first. I'm going to go into the World Properties tab, and then here where it says Color, I'm going to click on Color and make that black. All these grid lines, by the way, those don't show up in the render, but you can sort of preview what it would look like by turning off the overlays. So this is what our rendered image would look like if we turned the overlays off. I'm going to turn them back on for now, though. And now let's just give this cylinder a sort of a glowing material. So I'm going to click on it, click on the Material tab at the bottom right, click on New, and before, we saw this menu before, and all we did was change the base color, so we could like change it to red. But this is kind of like painting a cylinder red, which is not exactly what we want to do. We want this cylinder to be emitting light, which a laser really wouldn't do. But usually when we depict lasers, we depict them as if they were traveling through mist, and then there's sort of light scattering from all directions in a volume defined by a cylinder. In any case, here where it says the word surface and then principled BSDF, we're going to click there and we're going to change the surface type to an emission surface. And then we're going to change the color to whatever color we want the laser to be. So let's say in this case it's red. And depending on the kind of diagram you're trying to depict, we may already be done. But typically, if you're trying to make like a cover art or a diagram, with lasers, it's very common for some reason to have this sort of glowing effect. We associate those with laser beams for some reason. And so to do that, in older versions of Blender, it was a little faster. In the newer versions of Blender, it's a few extra clicks. What we're going to do is we're going to go into the compositor. So Blender has a built-in compositor. And to get to the compositor, we need to use these tabs at the top. So right now we're in the Layout tab. And then there's the Modeling tab, Sculpting tab, UV Editing tab, many, many tabs. And then if you keep going to the right, eventually you find the Compositing tab. And if we click on that, then there's this checkbox for Use Nodes. I don't know why it's off by default, but anyway, we want to check it. So we want to turn on these nodes. And there's a lot to be said about the nodes that we don't have time for. We're just going to add one node without explaining what any of these nodes mean. But we're going to press Shift-A, which Shift-A is to add objects in Blender, but now we're adding a node. And then we're going to search for one particular node. It's the glare node. So GLA, and then the glare node comes up. And we can just click it in between these two nodes, and it'll automatically connect them appropriately. And we just want to change where it says streaks. We're going to click on streaks and change it to bloom. And we're completely done in the compositor. We don't need to do anything else in the compositor now. We can go back to the Layout tab. And it still doesn't show a glow. We need to make one more adjustment, which is we have to tell Blender to please show us before rendering the compositing effect. So if I was to render this now, so if I went to render image, it should show the glow, I think. Maybe not. Okay, hang on. So to see it in the viewport, okay, I'm going to go up to the top right-hand corner here, and next to where this sphere is that we use to turn on rendering mode, there's a drop-down menu. And in the bottom here, it says Compositor Disabled Camera Always. So if we just click Always, then it should show us the glow. Okay, so maybe the reason that it doesn't is that the light is not strong enough emitting from the laser beam. So let's click on the laser. In the Material tab where we set the emission color to red and the strength was set to 1, let's increase the strength from 1 to say 20. Okay, there we go. So now we have a glowing laser. And so the reason it wasn't showing up before was, so if I go back here and disable the compositor, it will still show up when I render an image, but it doesn't show up as in the viewport. So you have to tell Blender, yes, I want to see it in the viewport. And then you can adjust the strength to your taste. So 20 is a lot. Maybe I want to just do 10 or 5 to adjust how subtle this glow effect is. And then if you want other colors of lasers, that's very simple. So if I was to duplicate this, so I press Shift-D, and then I'm just going to move it along the y-axis. I can copy this material by clicking this little copy icon. And here I'll just call this blue laser and change this color to blue. Or I can duplicate it, move it to the top, and again, copy the material and then say green laser, and I can make it green. And that is there's not much to it for making glowing lasers. And then I can render this and save it, and that is just how this image here was created. All right. I don't see any comments in the comments section, which is fine. I'm just saying, if at some point you wanted to interject, you can. But if there are no comments or interjections, I'm just going to move on to making graphene and hexagonal boron nitride and molybdenum disulfide. Okay?
Questions? Can you make the beams transparent?
You can make them transparent, yes. So here, let's do a quick test. So if I add some other object, so you can see a couple of issues here, right? So our green glowing laser beam not only is not transparent, but even worse is it's casting a shadow on the cylinder, which doesn't make any sense. But that can be, we can disable the shadow casting. So it's always dangerous to do these things in real time. But somewhere here there's a setting for turning, so saying that it's not going to cast a shadow. That's not it. But we can also make it transparent by, if we go to, so okay, I'm going to go to the material properties. One thing we can do is, there's a better way to do this, but I guess I'm thinking in real time. If we go back to this principled BSDF shader that we started with, here we can also give it an emission color, so I can make it green and say 10, for example. Okay, so it should look, hold on, we did 5. Okay, I want to make it the same as it was before. So this should be the same as what we had before. But I can also reduce this alpha value. So if I change this to be, say, 0.25, there's a, okay, wait a second. My computer's thinking. It's a little subtle, but I think it is now partially transparent. Here, maybe I need to lower this more. 0.1. Okay. You can fiddle with it, but I don't know if you can tell, but now it is transparent and glowing. Of course, they sort of compete with each other, these effects. If I keep lowering the alpha value, it gets more and more transparent, but at a certain point, the glowing is no longer. Anyway, the short answer is yes, but having it be see-through and glowing sort of fights the effect. I think the way you would implement this in practice, or rather, if you were trying to replicate the look of a laser passing through mist, is not that it has a uniform transparency, but you would have a sort of noisy transparency, so that it's like the density of the mist is changing, and so there are parts of it that are see-through and other parts that are not. Anyway, it's a good question. I don't have like a great immediate suggestion for if you wanted to do that effect beyond what I just said. Any other questions?
This is for the surface material. What about the volume material that Blender have? I mean, for instance, instead of the material you assign to this laser, if you go to the volume, it's transparent.
You can do that too, but I think if it depends what you're after. But if you wanted to, so I don't know who said that, but there's also a volume material where you set like the density of the volume and you assign the volume different properties, and the volume can emit light, it can scatter light, and I think in practice you would end up having something that looks identical, but would be much more computationally expensive. I think if you tried to create a volumetric region that was glowing, it wouldn't look much different than this. But you could, and it would also facilitate creating that, because you can create noise in that density. And so then you can replicate the fact that if you were spraying water or your mist was created some other way, that there would be a heterogeneous density. But I think for a lot of scientific diagram purposes, the way I described it here by using just the surface is a lot faster and simpler and sort of does the job. A lot of this also depends, are you trying to make, the cover of science, Or are you trying to make, you know, a figure in 5 minutes for a grant proposal that's due, right? So there's a lot of different choices one makes depending on the circumstances. All right, so speaking of being under the gun, how about I switch over to making graphene, since that was again one of the requests. So I'm going to open another instance of Blender. Okay, I should also point out, not that it makes a big difference, but that I am using, hey, where did my screencast keys go? Hang on. Okay. I'm using Blender version 4.4.3. They just came out just a few days ago with Blender 4.5, but almost everything I'm saying is the same. Okay, so let's make graphene. So in a longer tutorial workshop session, there's a whole discussion about a method using something called geometry nodes, which is very, very powerful, but has a higher overhead cost in terms of teaching. And I think for making something like graphene, it's using geometry nodes, I think, is a little bit overthinking the problem. We basically, all we want to do is we want to draw one unit cell of graphene and then just replicate it you know, along two vectors, which just requires using an array modifier. Okay, so let's make graphene. Okay, so I'm going to delete this cube by pressing the X key, and I'm going to add a sphere which will represent a carbon atom, or maybe a boron atom or a nitrogen atom. So I'm going to press Shift A, and I'm going to go to Mesh, and I'm going to choose icosphere. Both of these sphere options are essentially the same for our purposes. If we want to make a really large graphene sheet, we just want to make sure it doesn't have too many faces. But for our purposes, just the default icosphere is fine. And I'm going to right-click on it and say Shade Smooth. And then I'm just going to make it smaller. So if I press the N key, this properties window comes up, and it can show me that in Blender, the dimensions of this sphere are, you know, the default's to meters, but we can pretend it's angstroms or whatever. And it's 2 meters in diameter. I want to scale it by a factor of 10 smaller, so I'm going to say S, and then 0.1. And then I'm going to duplicate the sphere, Shift D, and then press X, and then press 1, or I'm going to say -1. Okay, so these two atoms, okay, whether it's carbon or boron or nitrogen, these are all the atoms in my unit cell. So if I pull up my PowerPoint slides, okay, this is a handy diagram for a unit cell of graphene. Okay, so you can see in this parallelogram, okay, there are just two atoms in the, there are only two whole atoms in this. Actually, this diagram actually doesn't illustrate it super well. So we can all see that there's one atom in the middle of the unit cell, and then, you know, the other atoms here are I should have picked a better diagram. Well, if you Google graphene unit cell, there are a lot of other equivalent unit cells that just sort of clearly show there are only two atoms. So we only need two atoms, and then we just need to know what these vectors are. Okay, so A1, so if the bond length between the carbon atoms, if we just say that it's 1, just for simplicity, we define our unit length to be a carbon-carbon bond as 1, then the A1 vector is going √3 times 1, or times whatever the bond length is, in the x direction. And our other vector, A2, is going this amount in the x direction and this amount in the y direction. So √3/2 in the x direction and 3/2 in the y direction. Okay, so knowing that, okay, we are just going to quickly give our atoms some sort of color. So I'm going to call this, say, I'm going to call it atom A and atom B, since it could be carbon or it could be some other atom identity. And maybe I'll just make the first one black, and I'll make the second one blue. And then I want to draw a bond between them, so I'm just going to do that with a cylinder. So I'm going to press Shift A, and I'm going to say Mesh, and add a cylinder, and I'm going to make it much smaller. So I'm going to press S and type 0.1, and I want to rotate it along the y-axis by 90 degrees. So I'm going to press R, Y, 90. And then I want to make it longer. And actually, I'll use the same trick I did for the MOF, which is I'll put my 3D cursor exactly in between these two atoms. So I'm going to select one, then select the other, then press Shift S and say cursor to selected. Then I'll click on my cylinder and say selection to cursor. And now I'm going to make my cylinder longer, but also narrower. So I'll press S, Shift X, 0.2, and then S, X, and then, I could work it out, or I could just eyeball it in this case. As long as it goes into each atom, it's fine. And then we could assign some color for the bond color. So we'll just do some sort of gray color for the bond. And I'll just adjust these properties. Okay, and so then we're actually almost done. I'm going to go into the top view by pressing 7 on the numpad. And I'm going to take this bond and I'm going to duplicate it. Hold on. I'm going to put my cursor my 3D cursor exactly inside my black atom. So I'm going to press Shift S and say cursor to selected, and I want to rotate this bond around my black, around the 3D cursor. So I'm going to make sure my pivot point, which is set up here, is set to 3D cursor. And now I'm going to duplicate my bond by pressing Shift D, and I'm going to rotate it on the Z-axis by 120 degrees. So I'm going to press R, Z, 120. And I'm going to do that again, Shift D, Enter, R, Z, 120. And this is everything I need to draw for my unit cell. So if I just select all of these objects, and then select my carbon atom at the center, and then join them together, so I press Control J. Now I have this one single object. So if I move it, it moves as one. And now I can just add an array modifier and just plug in my unit vectors, and now I can have, my surface. So to do that, I'm going to click on this wrench icon in this tab menu, click on Add Modifier. I'm going to search for array. And I am going to, in my case, I'm going to choose for the, I'm just going to rotate this, my starting, I've just written, the way I wrote my unit cell vectors, I just realized this would be easier if I just rotated this by 90 degrees. I'm going to rotate like this. Okay. It all works out either way. But so then I'm going to turn off relative offset, and in constant offset, I'm going to change I'm going to move along the x coordinate according to my A1 vector, which is √3 times the bond distance, which is 1. So √3 is just 1.72 something. Uh-oh. What did I do? Okay, sorry. Okay, so the one mistake I made is in Blender. If here, this is actually important because a lot of people will be frustrated later if I don't explain this. If I add an object, say I add a cube, and then I scale it by pressing the S key, and I make it bigger or smaller. And then if I press the N key, and then Blender tells me various properties about this cube, it remembers the scale factor I use. And then later, when I do other operations, it will multiply them by the scale factor. If I don't want Blender to, at a later point, multiply what I'm doing by a scaling factor, I need to tell Blender to forget that to just apply the scale factor, and you do that by pressing Control A and choosing scale. I had just forgotten to do that for my little graphene unit, and that's why initially I was not getting the result I expected. Okay, so back to where we were. There's an array count. If I increase the array count, then I'm going in my A1 vector. Now I want to also replicate this going into the A2 vector, so I just add another array modifier. I'm going to say add modifier search array. And the second array modifier is shown below. I'm going to turn off relative offset, turn on constant offset. I don't want this, whatever that is. And I'm going to go back to my calculation before. So I'm going to go along the x by √3/2, which is, I wrote this down, I think it's 0.866 or something, but I will just quickly double check. I see, okay, so it's 0.866. Blender will actually allow you to put in mathematical expressions here instead of the numbers. So I want to go this much along x and then along y. I want to go 1.5. So for the y, I'm going to type 1.5. And you can see we're starting to get our graphene, and we can increase the count like this and increase the count this way. And we can make this arbitrarily large. I'm just going to change my light to a sunlight so that everything is nicely illuminated. And I can decide, for example, that maybe later I decided, you know what, I really want these spheres to be larger, which is fine. I can just click on my graphene, go into edit mode by pressing the tab key. And I can just individually select any of these spheres by hovering my mouse over them, say over the carbon, and press L. And then I can scale it, making sure that I'm scaling by the median point. I'm going to press S and then say 2 to make it twice as big. And then I'm going to deselect by pressing Alt-A or just clicking somewhere else. Press L over the blue one, and then scaling by a factor of 2 if I wanted to, and then go back to edit mode. And so this is my graphene sheet or hexagonal boron nitride or whatever. And if there was a little bit more time, I could talk about how to just sort of clean up these edges. But let's just really quickly do molybdenum disulfide because it's very easy once you're at this point. Okay, so if I duplicate my entire sheet here, so I'm going to press Shift-D, and I'm just going to duplicate it along the z-axis, and I'll just say by 5 or something. So we'll have 1 below, and then up here, we're going to do our molybdenum disulfide. We don't really need to do very much, right? If we go to, do I have a reference? I have a reference. In case you didn't remember what molybdenum disulfide looks like, okay? It is just graphene, okay? Or you could say think it's like HBN, but where you take one of the atoms and you split it vertically in 2 directions, okay? So if we take our sheet here and we go into edit mode, okay, I can, for example, take my blue atom and say like that's going to be my sulfur atom. I can move it vertically. Let's see, by how much? I'm just going to be guessing right now, so I'm going to move it by 0.8. So I'm going to say GZ 0.8, and then I'm going to duplicate it, and then move the duplicate down by 1.6. So GZ minus 1.6. Okay, and then I can color it if I so wanted to. So I could copy this, and I can say this is going to be sulfur, and make this yellow. Okay, that's going to be the S in MOS2. And then I just need my bonds to be adjusted properly. So I'm just going to select. what I want to do is I want to select the tips of all 3 of my bonds. Okay, so I'm just going to press, I'm going to turn on this wireframe mode, which when I select my atoms, it will select all the atoms in front and behind. And I'm going to select this tip, and this tip. And I'm going to move it up by the same amount that I moved the atom, which was 0.8 in this case. I'm going to press GZ 0.8. And then I want to duplicate this, duplicate these bonds. So I'm going to press Control-L to make sure that all the vertices are selected. Then I'm going to duplicate it. And I'm going to make sure my pivot point is the 3D cursor. And then I'm going to flip it along the Z-axis. So I'm going to press S and Z and then -1. And then I'm going to get out of edit mode by pressing the Tab key. Now we have molybdenum disulfide, although we can make the black atom some other color. I think in the reference diagram it was a sort of bluish turquoise color, and there we have it. So there's our hexagonal boron nitride or graphene. Here's our molybdenum disulfide. Again, we can make these sheets as large as we want by just increasing the array count in either direction. Any questions? I realize we have 4 minutes left. It's probably a little ambitious to try and draw the metasurface in 4 minutes. Maybe the time is better served just addressing any questions if there are any.
Could you maybe not go into the full description of geometry nodes, but what would be the benefit? I mean, it seems like pretty straightforward to do it this way.
Yeah, I always worry that someone's going to say the opposite. So I think geometry nodes is just a lot more powerful, and in some ways, I think there's I guess within the Blender community, I think some people would argue that geometry nodes is this, is like the superset of functionality over using this old simple array modifier. But I think for any scientific visualization problem where there's a unit cell and you need to just draw the unit cell. And then repeat it along the unit cell vectors, I think just using an array is the straightforward path to do it. Okay, a question was, how can we create a defect, removing one atom and replacing with another one? Okay, great question, and actually it reminds me that there's another really simple thing I can show. So if I take my graphene sheet, I'm just going to call it graphene sheet even though we have 2 types of atoms. I'm going to make it a little bigger, and we're going to do 2 things. We're going to add a defect, and we're also going to make it a little bit wavy. I don't entirely understand why you'd make it wavy, but when on various cover art I've seen, sometimes it is depicted as like, not perfectly flat. Okay, so let's do that. So what I can do is I can apply the array modifier. So let's say I'm happy with the array of this size. Okay, so I'm going to there's a little drop down next to the array modifier, and I can hit apply. And I had 2 array modifiers. So I can apply one, and I can apply the other. And now this is like one large mesh object. And I can go into edit mode. And this is what I want to do. It's actually very, very easy. I can click on any vertex. So I'm not selecting spheres here. I'm just picking one vertex at random. And then I can turn on what's called soft select or proportional editing. Okay? And then when I press G, which is the hotkey to move it, it's going to okay, so that's not what I want. When you press G and then use the scroll wheel, hang on, bear with me. Make this larger. I'm a little bit annoyed. There should be a gray circle which I don't see appearing. But when you change the scroll wheel, it changes the size of the fall off, and it shows a little number in the top left-hand corner. And in any case, I can just pick arbitrarily regions of my graphene sheet and I can just move them up or down, and I can increase the size of this fall off to be larger or smaller. And then I have this like wavy surface, you know. So that's not exactly answering the question about the defects, but the defect is also really simple. So let's say I'm going to zoom in and I want to create a defect site right here. So I'm going to go into edit mode. Going to go into edit mode. Why is it not? Oh, hold on. I turned off the overlays. I'm going to go into edit mode. Okay. And then I want to say take this atom and delete it. So I hover my cursor over the atom and I'm going to press the L key. It selects all of the vertices. I can press X, delete the vertices. And then I don't want these dangling bonds, so I can just use box select all of these. And then I want to select all the vertices associated with those bonds. So the shortcut for that is Control L. And then I can press X to delete. And now I have a defect site. Okay, that wasn't so hard. And if I wanted to replace it with something and I want it to be at the exact center between these 3 carbon atoms, okay, I can hover my cursor over one of the carbon atoms, press L, oops, over one of the carbon atoms, press L, over the other carbon atom, press L, over the other carbon atom, press L. And now when I say put my cursor in between them, so I say Shift S, cursor to selected, now my cursor is exactly in between, I can Shift A, add another sphere, and I don't know, you know, I don't, at this point, I don't know what scientific idea I'm trying to convey, but maybe this is some larger atom or, you know, or something. But that's like a fairly easy way to do defects. All right, we've gone over time. That went way too fast, but you can go back and rewatch things. I normally go 100 times slower, but anyway, I hope this is of some help to you. I find Blender to, I have graduate students. I'm a professor. I force all my graduate students to learn it, and then once many of them learn it, and actually now many students in our department have learned it, it gets easier and easier for every new student subsequently to learn because the knowledge sort of spreads and it becomes this like tremendously flexible and powerful tool. So I highly recommend it.
Round of applause for Chris.
Right. Thank you so much for Dr. Chris Billman.
No, thank you for having me. It was a pleasure.
And